Hello everyone, my name is Iliasse Abdennour and today I'm very happy to present my project Anti-Load Modeling and Control Framework for Energy Sharing on a Microgrid Solar Automata approach. So as you see in this picture, 110 trillion US dollar is the investment by 2050 to achieve energy transformation, namely in renewable energy and energy efficiency. Normally, two factors behind this transformation. The first one is the commitment of government to implement energy efficiency programs and repent of climatic change, and second one is drastic reduction of renewable energy costs. For example, between 2010 and 2019, solar photovoltaic fell 82%, and this normally motivates people to use renewable sources to produce their own electricity, and that's what we call consumers become prosumers. But still some problem related to exploitation of that at a small scale for generation. The first one is the intermittent nature of renewable generation, and second is limited participation of consumers in energy market. So the concept of peer-to-peer energy sharing can offer a possible solution of that problem. The idea is very simple, is to connect several households and then they can exchange energy between each other. Our objective is to give a modeling and control framework for managed supply and demand decision, but this time using solar automata approach. What is solar automata? Solar automata is a discrete system in which space, time, and state are discrete. They can be defined by the equation 2-1 plus boundary and initial condition. Finally, we can say that the solar automata is a mutual interaction between cells governed by simple local rules. That means we start from simple local rules and then we can model a complex and dynamic system. The question now is how we can implement or applicate a solar automata for energy management. Actually, this figure give an answer for that question. They present the proposed approach of energy management in a microgrid, and actually is divided in two parts. In the first one, we run the solar automata to define the sender and receive address, and also the value and the price of the transfer, and then we validate the transaction using blockchain technology. Now, let me describe the SOA model. The Lattice is the microgrid structure composed of households connected to each other via the grid or power interface, and the state corresponds to the energy state of household, and we have defined 5 states: demand satisfied plus demand satisfied minus surplus power deficit, and grid connection. So the statue of a cell at the moment T is written via this configuration, and we can say that the state of a cell is a combination of 3 parameters: the amount of energy generated by renewable way, the consumed by load and stored in the batteries. We can of course compute the 3 parameters using equation 3.4, 3.5 and 3.6, and to validate our model we have used the collected data of Solar Decathlon Middle East 2019. This is the figure of the solar village of Solar Decathlon Middle East, and for simulation condition we consider 15 houses is the houses participate in the competition. Time step 30 minutes for 1 day of simulation, that means 24 hours. Initial condition, we suppose that all the batteries are full charged in the beginning of simulation, and for state connotation we consider this color to represent the state, and for the input of our model we consider the PV production of each house, demand profile, the grid excess injection, and grid consumption. Okay, this is the simulation result, and we can say that it's divided into 3 parts. The first one is from iteration 0 to 18. Supply and demand is well balanced. There is no exchange of energy between neighborhood. It's normal because there is not any solar radiation. And the second part, from iteration 20 to 24, solar automata is in action. Neighborhood with excess energy automatically exchange the requested energy to balance the energy flow. And the last part is from 6 p.m. to 11 p.m. Energy exchange is stopped at 7 p.m. due to the lack of solar radiation. That's all. Thank you for your attention.